Hey everyone, welcome back to our YouTube channel. Today we'll be taking off for the retaining wall using the CESMM4. So I'll be able to go through it and I'll be able to show you how you use the CESMM to get the descriptions and also the measurements for the retaining walls. In our previous video, we discussed about how to use CESMM and the sections in the CESMM4. So today we'll be practically going through the CESMM and doing the retaining wall takeoff. On the screen you can see there's a takeoff for the retaining wall here, as in there's the section of the wall which has a width of 3500 in the foundation and 1550 is outside the foundation, outside the wall. Then 1500 is where the wall occupies, and 450 is for the pier behind the wall. So we can see that there are piers which are at 4-meter centers. The concrete in the wall is 1:2:4 reinforced concrete. Then there's a whip hole which is 150 millimeters whip hole at 2-meter centers. So along the length of the wall, for the centers of after every 2 meters we have our 50 millimeters whip hole. Then there is a continuous pocket of ballast between the piers. So between each pier, every pair of pier, we have continuous pockets of ballast. The measurements for the ballast, we can see it's 450, the width. Then we are not given for the height, but it's usually mostly a square, so it will be 450 by 450, continuous pockets of ballast. Then we have the foundation, which is made up of ratio 1:3:6 mass concrete to the foundation. The thickness of the foundation is 600. 400 will be the distance between the foundation and the ground level. Then 4500 will be the height above the ground for the wall. So the total height of the wall and the foundation is 5500. Then we are given the thickness of the wall up here. So 450 is for the pier, 450 is for the thickness of the wall up there. Then 1050 is between where the wall stops at the upper side until where it stops at the below side, because you can see the wall is like a trapezium. The upper side is narrower than the bottom side. Then 1550 it's where the foundation spreads outside the wall. Okay, so that is the section of the wall. When it comes to the plan, we can see that this is the pier. The pier is 900 millimeters wide, and the thickness of the pier is 450, just as we have seen in the section. Then the wall from the top, we can see it's 450 millimeters wide, so it spreads up to here. Then the foundation spreads up to this line. All right, so I hope you have understood the drawing, and once you understand the drawing, now you are good to start taking off. So whenever we are taking off using CESMM, just as we do in normal taking off, we come up with a takeoff list. So for the takeoff list for that we will come up with in the CESMM, it is always guided by the classifications of work. Okay, when we discussed about CESMM, we saw the part for work classification. And if we can look at CESMM4, this one I have opened, we shall see the work classifications. It is in section 8. Section 8, let's go to section 8. We'll be able to see all those classifications of work. Work classification, these classes are the ones that will guide us as we do the takeoff list. When we are doing the retaining wall, we know that we need to do the demolitions and site clearance before we start any taking off. So the demolitions and site clearance, we shall look for it here. We shall find it is in class D. You see, you'll just go through these classes and ask yourselves, are there general items when you're taking off? No. Then we have ground investigation. That one is not in the retaining wall. Geotechnical and other specialist processes? No. So the first one we'll come across is the demolition and site clearance. That is class D. Okay, and this is because if you look at the drawing, we had been told in the notes, in the notes here, let us zoom into the notes. We had been told that the wall is 60 meters long. Okay, I can see that you can see it very well, but it states that the wall is 60 meters long. The design concrete grade is class 20, 30 millimeters aggregate to be used. Okay, then filling material to be rock. We shall fill using the rock. So we haven't been told about any site clearance here, but we will assume that we shall do site clearance when we are taking off. You know, sometimes once it's given, we do it. Sometimes if it's not given, we still assume it's done. So we shall measure for site clearance. Then we shall assume there's no demolitions in our case. So in our classes, in class D, we shall deal with demolition and site clearance. Then the next one will be earthworks. Earthworks usually, let's open class D so that you can be able to see these classes. Class D, that is class A, class B. You see, if you go through these classes, you'll be able to see what these classes involves. And right now, I want us to look at class D because it is the one that deals with demolitions and site clearance. Okay, so in under demolitions and class site clearance, we can see that you can measure site clearance, you can measure any trees that are on site, the stumps, the buildings that you're going to demolish, the pipelines that you're going to remove. You see, but in our drawing, we haven't been told about any demolitions to be done or the site clearance. So that's why we'll only do site clearance, the general site clearance. Then we will go to earthworks. Earthworks. The earthworks usually involves excavation by dredging, excavation by cuttings, excavation for foundation. In our case here, we have seen that the foundation for the retaining wall, it requires us to do excavation for foundation. Then it also usually covers general excavations. That is class E. So we know that we will be doing earthworks. Okay. So earthworks, the first thing we shall do is excavation for foundation. Then once we excavate, we will always do excavation auxiliaries. Okay. So if you go to class E, if you peruse and pass the rules, the rules here, you in page 34 there is excavation auxiliaries. I hope this is very visible. Let me try to make it as visible as possible. There are the excavation auxiliaries here. So the excavation auxiliaries, they include trimming of excavated surfaces, preparation of excavated surfaces, disposal of excavated materials, double handling of excavated material, dredging to remove seals, excavation of material below the final surface and replacement with slated material, timber support left in, and metal support left in. So in our case, if we excavate for the foundations, that soil should be disposed. So that one will be found in excavation auxiliaries. Once we are laying hardcore or anything, if we are laying hardcore, we need to prepare you need to prepare the excavated surfaces. Okay. Double handling of excavated material. If you want to know what double handling means, you will just come here to the rules and see what it says about double handling. You see where we have the measurement rules, it explains to you double handling of excavated material shall be measured only to the extent that it is expressly required. The volume measured for double handling shall be that of the void formed in the temporary stockpile from which the material is removed. If you want to know about the trimming of excavated surfaces, how it should be measured, you are told trimming of excavated surfaces shall be measured to surfaces which are to receive no permanent works, whereby whether trimming is expressly required or not. You remember what we talked about expressly required there? Yeah, so those are some of the terms that are used in the bill of quantity. And if you want to know, you just go to where we cover this in chapter 1, the terms and definitions that you're going to experience when you're taking off using the CESMM4. So once we are doing earthwork, we shall cover excavation of trenches, excavation auxiliaries, everything that follows excavation. We shall do the filling, anything that revolves around filling with hard coal, filling with concrete, anything. Then we shall go to filling auxiliaries. Okay, so the next part of Class E is filling. You can see we have filling to structures, filling to embankments, general filling to stated depth of thicknesses. If you look at the third division, it explains more about the second division. It is filling to structures. It can be using excavated topsoil, imported topsoil, non-selected excavated material other than topsoil or rock, selected excavated material other than topsoil or rock. You see, eh? Now, after doing the excavation, we shall fill, do the filling. Whatever we shall use, for example, in our drawing. In our drawing, we can see that there is here, there is filling. Here, like here above the foundation, we shall fill. We shall fill it with some material, maybe not topsoil, or rock, or hard materials, anything. That one we shall measure it. We shall measure the filling, then filling auxiliaries. Let's see what filling auxiliaries involve. Filling auxiliaries, it involves trimming of filled surfaces, preparation of filled surfaces. Trimming, it includes topsoil material other than topsoil, rock, or artificial hard material rock, stated artificial hard material. So, the four things that you'll be doing under earthworks, it's excavation of foundations, excavation auxiliaries, filling, and filling auxiliaries. After that, we will move to Class F. Class F talks about in situ concrete. In situ concrete, it talks about provision of concrete. You can see it's provision of concrete, and also Class F also talks about placing of concrete. First of all, it's how we provide concrete. Then the second thing, how we place the concrete. If you want to know more about the provision of concrete, how it should measure, you shall come to the measurement rules. The volumes of concrete measured shall include that occupied by reinforcement and other metal sections, pre-stressing components, casting components, such. So, we shall provide the concrete, measure for the provision of concrete, then also placing of the concrete. Then, we shall go to concrete auxiliaries. And concrete auxiliaries is in Class G. Class G, concrete auxiliaries. It involves formwork for in situ concrete, reinforcement for in situ concrete, joints in situ concrete, post-tensioned, pre-stressing, accessories for in situ concrete. So Class G involves the formwork, the reinforcement, and the concrete accessories. So I wanted to go through the taking off of the retaining wall one bit by bit. You see, concrete accessories involves the inserts such as the whip holes, the PVC pipes. Okay, then we should measure the formwork that will be used to hold the retaining wall. Placing of concrete, we shall measure the concrete in the foundations and concrete above the foundations, concrete in the piers. Alright, yes, so we will get on to taking off the retaining wall. Right, so when you're taking off the retaining wall, just as you said, once you read the checklist, then you will come to take off one by one. So we will start with the side clearance. So we'll go back to the drawing. We have seen that the wall, we have been told, is 60 meters long. Okay, so when we are doing site clearance, the general site clearance, we shall take the length of the wall, then the width of the foundation. All that area is where we shall excavate. You see, the length, then the width from the end to the end here. So 60 meters, 3.5. When you are writing the description using the CSMM, we only follow what is in the CSMM. So we shall go to Class D. We shall see general site clearance, and we shall say general clearance. It should be measured in hectares. Okay, so to measure in hectares, we shall need to find the area first in meters squared, then we shall convert it to hectares. So it shall be 60 meters by 3.5 meters wide. So we shall write general clearance. For the coding, it is class B, first division 1. Then second division, it is 1 again. Alright. Then for that division, because there's nothing, it's 0. So D110. Okay. So let's go to excavation, which is in class E. Then we'll be excavating for the foundations. Okay. So when we are excavating for the foundations, we shall take the length of the wall times the width of the whole foundation, which is 3.5. Okay, so because we want to measure foundation, we shall go to class E, which is earthworks. Then we shall go excavation of foundations. It should be in meter cubed. I hope you can see here very well. It should be in meters cubed. So if excavation of foundation is in meters cubed, then we should take the length, the width, and the depth. And once it's in meters cubed, we have been told if we are excavating, we shall start first with excavating the topsoil before we excavate up to the bottom of the foundation. Once we are excavating the topsoil, we shall take excavating of topsoil will also be in meter cubed. You see, once you're excavating, you should state the depth. So it will learn if the topsoil was like 150 millimeters. In our case, we have assumed 150 millimeters for the topsoil, and because we were not given the drawing. Remember, we have to do a query sheet so that we can be able to know what is the depth of the topsoil. So we shall write excavation for foundation trenches. We shall do a query sheet asking ourselves what is the average depth of topsoil because we haven't been given, and we shall give the answer is 150 millimeters. So remember, when we are doing the description, it should be, let's do the description. Excavation for foundation, topsoil, which is in second division, maximum depth not exceeding 0.25 meters. It should be in meters cubed. Then the citation should be E for E class E, E3, E3, 1 for topsoil, 1, E3, 1, 1. Then we want to know, we already know for the topsoil, it shall be 150. It is 60 meters, 3.5 meters wide, 0.15 meters for the topsoil. And we have already stated how you'll get this description and the code. So we shall go to the next item, which is excavation auxiliaries disposal of excavated material. You see, once we excavate the topsoil, it should be disposed. So we shall go to excavation auxiliaries. That is still in class E. So we shall go to CESMM, class E. Then we shall go to excavation auxiliaries. So when we are in excavation auxiliaries, we shall go to disposal. Excavation auxiliaries, disposal of excavated material. You see here, we have been told excavation auxiliaries in part 3, disposal of excavated material, then topsoil, because we need to remove it from site. And remember, in CESMM, we only use descriptions as given by the CESMM. So we shall write excavation auxiliaries, disposal of excavated material, topsoil. And the code is class E, E5 in division 1. There is 3 in division 2 and 1 in division 3. So it shall be E531. So how you measure it? It is the length 60 meters, 3.5 meters wide. Then the depth for topsoil that you'll be needing to dispose is 0.15. Okay, so we will go now to excavation for the foundation material other than topsoil. After topsoil now, we need to excavate any other material other than topsoil. And before we do that, we need to know what is the total depth of excavation. You see, the total depth from the ground level was 400 plus 600. Then that gives us 1,000. We have already excavated 150 for the topsoil. So 1,000 minus 150 shall be 850. So what will be the volume of soil? Because if we go to excavation auxiliaries, let's go back to excavation auxiliaries. Excavation, we shall go to excavation first because we want to excavate first. We excavated the topsoil, now we are excavating for foundations. Material other than topsoil. You see, we have it here. Now we were done with topsoil. Now it is material other than topsoil. So once we are quoting, it should be E3 for excavation for foundation, 2 for second division, then 0.85 will land on 0.5 to 1 meter. So it shall be E3, 2, 3. You see, class E3 excavation for foundations, 2 material other than topsoil, rock or artificial hard material, and you have to copy just that. Then you go to 0.5 to 1 meter. 3. And that is what we have here, E3 to 3. Excavation of foundation, material other than topsoil, rock or artificial hard material, maximum depth 0.5 to 1 meter. So we shall take the total length of the wall 60, the width 3.5, and the depth 0.85. Then for also that material other than topsoil, though we do not know what it is, all we know it's not topsoil and it's not rock or any other artificial hard material. It's the natural material that was there. We shall need to dispose it. All right. So so we shall come to, once we excavate it, we shall add excavation auxiliaries. Okay, we shall dispose of excavated material other than topsoil, rock, and artificial material. Once we are going to artificial excavation auxiliaries, that's when we know we always go to the other part of class E, where we have the excavation auxiliaries. So it will be E5 excavation auxiliaries, then it shall be disposal of excavated material other than topsoil, rock, or artificial hard material. So E5, 3, 2. E5, 3, 2. The same volume of soil that we shall excavate, we shall dispose it. Alright? So after disposing that soil, now we should go to the next part. You see, we have done an excavation for foundation and excavation auxiliaries while disposing the soil. But now, after disposing the soil, if you look at the excavation auxiliaries, there is disposal, then there is preparation of excavated surfaces. We need to prepare so that it can come and receive any other material like the rock that will be imported. Because if you go to our drawing here, this part above the foundation, you see, oh okay, we have excavated the foundation. We need now to compact the ground so that it can receive the foundation concrete. We need to compact the ground so that it can receive foundation concrete. So for that part of preparing the excavated surface, we shall take off that one as excavation auxiliaries, preparation of excavated surfaces, material other than topsoil. Let's go to the CESMM. We shall get it from CESMM. Everything in the CESMM we get from CESMM. So excavation auxiliaries, preparation of excavated surfaces. So it shall be E5 to 2. Material other than topsoil and artificial hard material. So preparation of excavated surfaces. Yes, material other than topsoil, because it will not preparing anything relating to topsoil. We want to compact the ground, and also we want to support the sides of the excavation. All right. So once we are compacting, it shall be 60 by 3.5. a total length 60 by 3.5. Then we shall now support the sides of excavation where we do not have topsoil. We shall take the total length 60, then we shall support each side. So 60 times the depth of excavation which did not involve topsoil. It shall be 0.85 for the two sides. So the areas to be supported shall be 60 meters by 0.85 two sides. Then the other one shall be 3.5 meters the width. Let's go back to the drawing so that you can be able to see where we are getting this from. 60 is the length. Then the width of the retaining wall is 3.5. So it shall be 3.5 times 0.85 up to where we have with the topsoil starts. So it shall be 3.5 and 0.8. Remember, when we are digging the foundation, it is a rectangle. A rectangle whose length is 60 meters, then the width is 3.5. So the supporting the sides for the length shall be 60 meters and the height 0.85. For the width it shall be 3.5 meters and the height 0.85. Then we shall support the soil where we have topsoil. So that one is preparation. It is still under excavation auxiliaries, preparation of excavated surfaces, but to topsoil. That's why we write ditto as above. Ditto, but topsoil. So we shall take the length again 60 meters, the height 0.5 times 2. Then for the width 3.5 times 0.15 times 2. Okay, now that we are done with excavation, compacting the ground, then supporting the sides, we shall now we start filling. Okay, now we are done with the first and with the first part, which was site clearance, we were done. We are still on earthworks. Earthworks involves all the four things. We have excavation auxiliaries, which involve disposal of soil, supporting the sides of excavated surfaces, and also compacting the ground. Now we go to filling. Now, in filling, we want to fill. You see, our filling is still in class E. We shall go to CESMM. Once we go to CESMM, we shall go to class E. We're in class E, whereby we shall be dealing with filling. Okay, we are told that we can fill to structures, we can fill to embankments, we can do general filling, or we can do filling to stated depth or thickness. Now, in our case here, we want to fill the foundation using imported rock. Where are we filling? Okay, you see in our drawing here, we have been given a filling that we need to do. You see, where we shall do filling is where we do not have the concrete here. You see here, we shall fill using rock. Okay? Yes, because once we do the concrete, then the concrete for the walls and the piers. Here we need to do the filling using rock. So how do we measure that? We shall just take the whole 60 meters. We shall take 60 meters. Then we shall multiply by the total 3.5. Then we shall multiply by 0.4 where we shall fill. Then we shall deduct this other area here. You see, we shall measure like we are filling the whole area here. Then we shall deduct where we are not filling. Okay, so when you are measuring for the filling, we shall take the total length 60 meters, the width is 3.5, then the depth is 0.4. Then we shall deduct all the area that we shall do concrete, because we shall not be able to do filling with imported rock. So before we go to that, let's see from the system how we fill using imported rock. You see, when you are filling, you see, if you want to understand anything, filling to structures, filling to embankments, you only need to come to the rules here. You see, like here, it is well explained to you where these fillings usually happen differently. We have filling of excavation around completed structures should be measured only to the extent that the volume filled is also measured as excavation in accordance to rule M6. All these rules should guide you to know where this filling should be used. Now, for our case, we want to do filling to structures. This filling will not be to embankment. Embankment is where we have water. Then we have general filling stated. Ours will be filling to structures. A retaining wall is one of the structures. So we shall be doing filling to structures. Then we shall be doing using imported rock, because for that one, where we have the filling above the concrete for the retaining wall, we can only fill using rock. So once we are getting the quotation, the coding, it shall be class E filling structures imported rock. So it shall be E617. You see, imported rock is number 7 here. Imported rock. So, when we are measuring, we have said we shall measure the whole area, which is 60 meters long, 3.5, then 0.4. Then we shall deduct where we do not have the filling using concrete. So here we can see we are calculating the number of piers. The piers, we had been told that the piers are 4 meter centers. The total length of the wall is 60 meters. So to get the number of piers, it shall be 60 divided by 4, then 4 meters plus 1 pier. So 60 meters divided by 4 meters plus 1. We shall get 16 piers. So when we are coming to deduct, we shall take this volume here. First, we shall deduct this volume in the wall. So it shall be 60 meters long, 1.5 for the wall, then height 0.4 for the wall. Then for the pier here, it shall be how many piers? You see, we shall be filling everywhere except where we have piers. You see, for the piers, they are only appearing after every 4 meters. So between the piers, we shall have the imported rock. That's why we are only deducting. The wall will be continuous from end to end, but the piers will appear 16 times the volume of 1 pier. So it shall be 16 times 0.9. 0.9 is the width of the pier times 0.45 times 0.4, the height. Okay, 0.4. So 0.9 times 0.45 times 0.4. This one, 16 piers. All right. So it shall be the total. We have said we shall fill using imported rock. The imported rock shall cover where we do not have the wall and where between the piers are the same level. Okay, so we shall deduct the length of the wall times the width of the wall, 1.5 times the thickness, the depth where the imported rock should be placed. Then we multiply the number of piers times the length of a pier, the width of the pier, and the depth where filling should take place. So the next part we should go to is doing the ballast. Where shall we be doing the ballast? You see, ballast shall be done everywhere we do not have the piers. Where we do not have the piers, we shall do ballast. Then, you see, in the drawing, we had been told there are continuous pockets of ballast between the piers. So, whenever we do not have the piers, between the piers, we shall have ballast. Okay? Now, if we will be doing filling behind the wall, we shall be doing filling behind the wall. Where we do not have the piers, we will have the ballast. Then the ballast, we had been told it is the ballast, we can see the width of it is 450. Then the ballast do not go the full length. It is just like a square. So it shall be 450 by 450. But the length of the ballast shall be the length between the piers. Okay. So for the ballast, it shall be the total length between the piers. So if the total wall was 60 meters, we shall deduct number of piers, which is 16, Then we shall multiply by the length of one pier. So 16 times 900, we shall get 14,400. So we shall take 60 meters, we deduct 14,400, we get 46,400. That is the total length where the ballast will be, the continuous pocket of ballast will be. So 45.6. Then we shall multiply by 0.5 for the length of the continuous pocket and 0.45 for the thickness of the continuous pocket. Then in this one, we shall find it in filling. In the CESMM, go to CESMM. In filling, you see in filling, we shall fill two structures because it's the retaining wall. Then we shall do, let's reduce this. We shall do filling two structures, that is EC1. Then we shall fill using ballast. Ballast is usually imported rock. Okay, so it shall be E617. But because we had another 7, actually this 7 should be E617.1. This one should be E617.2. Just as we said in the rules for using CESMM. So it shall be filling. We shall use in the description filling to structures imported rock. Okay, yeah, imported rock. You can just write filling to structures imported rock, or you can say filling to structures continuous pocket of ballast into bracket imported rock, to be specific. Yeah, because you see, if it's imported rock and you're quoting it again, you need to be a bit specific. You can say continuous pocket of ballast. So let's go to the next part, which is preparation of field surfaces, the rock. Okay, now we shall go back to our drawing. When we want to prepare the surface for the rock, preparing the field surface, we need maybe to compact it after the filling. We need to measure it. We need to measure now filling auxiliaries after filling. We need to compact it. So how we measure it? We shall take the total length, then we shall deduct where we will not be doing the imported one. So it shall be 60 times 3.5. Then we shall deduct this surface for the wall and for the where we have the piers. Alright, so we shall deduct 60 times 1.5, then we deduct again 16 piers times 0.9 for the length and 0.4 for the length. Alright, the areas that we will not need to compact after filling using the rock. Then now we should need to go to in situ concrete. You see, when we are taking off using CESMM, I hope you have realized it's not like when you are using the SMM, because in SMM the order has to be maintained, how things happen. But in CESMM we usually group activities that they are done. Like now we were doing earthworks. Earthworks, we were supposed to go to earthworks. Then we should cover everything in earthworks, starting from we just go to CESMM, then we go to earthworks. Class E, we did, you see, it includes it told us what it includes: the excavation, the filling, the compaction, the disposal. You see all that. After we are done with the earthworks, now we go to in situ concrete, and in situ concrete is in class F. All right, yes. So in situ concrete is that concrete in the foundation and also the concrete in the walls. Alright, so once we come to the in situ concrete, you can see it here. We are told that the in situ concrete, it includes, we are just told what it excludes here. But if we look at the in situ concrete, we are told there is provision of concrete, then there is the placing of concrete. Right, so in situ concrete there will be provision of concrete, then in the next part we shall have the placing of concrete. So let us measure for the provision of concrete. So in the provision of concrete, we shall go back to our drawing and we shall see that the wall is 60 meters long, the width is 3.5, then the concrete in the foundation is 600. Okay, so 60, 0.5 and 0.6. Then when we are writing the descriptions, we shall go to, we start with the provision of concrete because that's when we are providing for it. So we shall go to designed concrete, provision of concrete. We have written as the heading. Subheading, it shall be designed concrete. Class 20 is to 25. We had already been told in the notes. Provision of concrete, designed concrete, class 20 stroke 25. Then maximum aggregate size, we had been told, is 20 millimeters. So when we are writing the coding for that, it shall be F, class F, 1, first division 1, second division 4, then third division 2. Alright, so design concrete grade C, grade class 20 stroke 25, aggregate size 20 millimeters. The code will be F142. Then this shall be 0.1 because there is a 0.2. There's still another designed concrete grade 20 stroke 25, aggregate size 20 millimeters in the next part. So in the next one, let's go back to our drawing. We have already provided this concrete. Now let us provide for the concrete in the wall and in the piers. Okay, so for the wall, we shall take the total length of the wall, which is 60 meters. Then the top of the wall is for 50 millimeters wide. The bottom is 1500. So what is the average width for the wall? For 50 plus 1500, 1950 divided by 2, 975. So it shall be 60 meters, 0.95. Then the height shall be 4.9. Okay, so it shall be design concrete grade class 20 stroke 25, 1:2:4, aggregate size 20 millimeters. Okay, so when you are quoting, it shall be F1 for class F1 first division, 4 second division, 2 third division, part 2. We have repeated that description. Okay, so once you repeat for a different item, you just have to write 0.2. So it shall be 60 meters for the wall. Let's go back to the drawing. So it shall be 60 millimeters for the wall, 0.9, that is the width of the wall, average width of the wall. Then the height shall be 4.9. For the piers, it shall be 16 piers. The length of each pier is 0.9. The width is 0.45. Then the depth of the pier shall be 4.9, where we shall do the concrete, because the concrete starts above this foundation concrete up to the top. Alright, okay, so let's go to the placing of concrete. You see, placing of concrete is that whole process of putting that concrete in place, and usually measure it differently from provision of concrete in the CESMM. So we shall measure the placing of concrete in the foundation, then the placing of concrete for the walls, because as guided by the CESMM, if we come to the CESMM, we shall see that in the placing of concrete, we can place the mass concrete, that one is in the foundation, then we shall place the reinforced concrete differently. Then when we come to reinforced concrete, we shall place the walls differently. Alright, so once we are placing the mass concrete, it should be in meters cubed. So we shall take the length 60, the width 3.5, the depth 0.6, mass footings, thickness exceeding 500 millimeters. Alright, so mass footings, thickness exceeding 500 millimeters. So it shall be class F, mass 6 in the first division, shall be 2 in the, you see, these are bases, footings, spile caps, and ground slabs. That is where the foundation concrete lies. Then the thickness, because it is 600, it shall lie in the 300, exceeding 500. Okay, so once you're writing the description, it shall be placing of concrete as the heading. Then the subheading will be mass, bases, footings, pile caps. You choose yours. Which one applies? It's the footing. Thickness exceeding 500 millimeters. Okay, so it shall be class F, 6 first division, 2 second division, and 4 third division. Shall be F624. 60 meters long, 3.5 meters wide, 0.6 depth. That is the volume of concrete in the footings. Then now we go to the volume of concrete in the walls, and the walls shall be reinforced. So we shall go to reinforced. That is item number 7 in the first division. Then shall be walls, item number 4 in the second division. Then for the walls, you see the average thickness of the wall is 4.9. We had already calculated it here. 450 plus 1500, we got 975. Okay, so 975, it exceeds 500 millimeters thick. Okay, so we shall write the total length 60, the wind is 0.98 as the average thickness of the wall. Then the height of the wall shall be 4.9. That is the placing of concrete. Now, placing of concrete in the wall. Placing of concrete in the piers, how shall it be? For the piers, if you look at the CESMM, which should guide us, we are told that you see, there's a separation here between the placing of concrete for the walls and the blinding and the bases, footings and the suspended slab. It's separate from the column piers, beams, and casing to metal sections. If you come to columns, piers, you should measure them out using the cross section, not the thickness. So if you come to piers, we have to find the cross section area of the pier. So for the cross section area of the pier, you see the length of the pier is 0.9 and the width is 0.45. So it shall be 0.9 times 0.45. We get 0.405 meters cubed. Okay, so we shall take 0.9 times 0.45. We get 0.45 meters cubed. Then once we are coming to get the description, we shall say placing of concrete is the heading. Reinforced column piers. It is piers now because you see ours is piers. Cross section area, we have got 0.405. So it lies between 0.25 to 1 meter squared. So it shall be class F, first division 7, second division 5, then third division 4. 7, 5, 4. That should be 4. Between 0.25 to 1 meter squared. So here is the mistakes. Should be F754. 16 piers, length 0.9, width 0.45, then the depth is 4.90. So when you are placing concrete for the piers, we should take the cross section area. Then we shall go to concrete auxiliaries. Concrete auxiliaries still under class. No, you see, concrete auxiliaries is under class G. Okay, class G, we have the concrete auxiliaries, which involves the formwork, the reinforcements, the joints, the prestations, stressing, and the auxiliaries in situ concrete. Okay, so we want to take off all the formwork that we shall use. So that we can take the formwork, we shall calculate the formwork for the fair finish. You see, in our drawings here, we had been told where we have the fair finish, we have the rough finish. Okay, so first of all, we want to calculate the concrete for the fair finish, where we have, you see, there's this sloping surface here. We have this sloping surface here. So we have the concrete auxiliaries. When you are measuring the formwork, let's go to concrete auxiliaries formwork. We have formwork to rough finish to fair finish. other stated finish, stated surface finish. Okay, ours, we shall take a fair finish because it's the retaining wall and it shall be above the ground. So you need a fair finish, not a finish, because we do not come to do any other finishing to it. It is the part that be exposed to the climate. So ours will be fair finish. Then fair finish, then we will start with the fair finish behind the wall. Okay, so the total length of the wall is 60. The total depth of the wall is 4.9. The formwork that we shall use to hold the concrete above for the wall at the back side, it shall be 60 meters by 4.9 meters. So the total area, you see, it is measured in, let's see, it is measured in, you see, we are told for the plain vertical side, we are told it is measured if the width is between 0.4 to 1.22 meters squared. It is measured in area. If it is 0.2 to 0.4 meters, measured in meters squared. If it is 0.1 to 0.2 meters, measured in linear meters. Ours, it is the width is exceeding 1.22 meters. The width of the retaining wall, it is exceeding 1.22 meters, because the width of the retaining wall, you see, it is 1.5, right? So if we are taking off concrete and we have been told, you can classify them within these ones, either 0.2 to 0.4, 0.4 to 1.22, or exceeding 1.22. The width of our wall below there is 1500. All right, so if we take 1500, it exceeds 1.22 meters. So for the area of the formwork, it shall be fair finish, plain sloping, plain sloping. Sloping, if it's sloping, it is this one that is this way, this part. We shall measure it. If the width is exceeding 1.22 meters, it is measured in meters squared. So we shall take the total length of the wall times 4.9. Then this one, we shall say the same will apply to plain vertical. This formwork will be the same as this side. So detail but plain vertical, 60 meters by 4.9. Then for the descriptions where we get them, we shall go to class G, 2 fair finish, 2 again plain sloping, plain sloping for the sloping one, then exceeding 1.2. So it shall be G 2 4 G2 4 5, G2 2 5 for the plain sloping, because 2 is for the plain sloping. But for the vertical, it shall be G plus G2 fair finish, then plain vertical 4, then 5. Okay, so that is for the formwork. That is for the formwork. Then we shall go to formwork. You see, we continue here. We shall deduct the formwork that will be covering the, you see that area we have covered for the plain vertical. We have included the piers, but the piers will have their own formwork. So we shall deduct the number of piers times the length of each pier times the width of each pier. Then we shall save that formwork. We shall deduct the last item. For the plain vertical, we shall deduct the last item for the piers. Okay. Then, and also fair finish plain vertical width 0.4 to 1.22 meters, G2 44. And fair finish plain vertical width 0.4 to 0.4 to 1.22 meters. You see, we had measured the plain fair finish in the auxiliaries, we had accounted for fair finish to be in the whole wall, the vertical wall behind there. But now we can deduct the one where the piers will appear. So that's why we are saying we also deduct the fair finish, the plain vertical, that width of the piers. The width of the piers is 0.45, so it lies within width 0.4 to 1.22 meters. The quotation is G244. Okay, so then we shall conclude. We are almost concluding. Then we shall do formwork for the sides, the wind sides of the wall. So, and the piers. So we have 16 piers. Two sides of the piers, the sides, the wind is 0.45, then the height is 4.9, then we have two sides of the length, which is 0.98 the length, then the height is 4.90. So this one is ditto. Ditto is this formwork that was here, fair finish, but to piers. You see, this is formwork for the piers, and we are told it is for the extreme sides of retaining wall average wind. No. Okay, now we shall come to taking off the formwork for the retaining wall, the wind sides. The wind of the retaining walls was 0.45. The height is 4.9. We have two sides. We will now conclude that part with concrete and auxiliaries. If you look at the CESMM, it states that concrete auxiliaries includes the formwork, the reinforcements, the joints, the post-tensioned pre-stressing, and the accessories for in-situ concrete. The accessories for in-situ concrete in this case will involve this part, the insert 100 millimeters PVC pipe, insert for wheat poles. That one will lie in the concrete accessories. For the formwork, we want to calculate the formwork for the retaining wall. So if we want to know, first of all, we shall look at the drawing. The formwork will look at the formwork for the sloping side, for the vertical side. Then we will look at the formwork for the sides of the retaining wall, this side and the other side, remembering the formwork for the piers. Okay, so we'll start with this for the sloping side. To calculate the formwork for the sloping side, we will refer from the CESMM, and it says that if we want formwork for the plain sloping, we shall look at formwork. Ours we want a fair finish because it's a retaining wall and it will go above the ground. Because we do not want to maybe do pass. We may, even if we want to do plaster or something of the sort, maybe most likely we are not doing tiling, so we'll need a fair finish. So we'll choose fair finish, then plain sloping. Then we look at the thickness of the wall. The width of the wall, we will consider the width of the retaining wall below here. Okay, so if it exceeds the width here is 1.5, then we'll go to the CESMM to see where it lies. 1.5 lies here where it's exceeding 1.22 meters. So we'll measure in meters squared. So the width will be, okay, it shall be 4.9, that is the height. We will take the height times the length. For the sloping soffit, you see, this is the sloping side, then the vertical side. They take the total length of the wall, which is 60 meters, then the height of the sloping soffits will just take the vertical side, the vertical height. Okay, we'll just consider the vertical height, which is 4.9, the wall from here to here, 4.9 times 60 meters. That one is the one that we will use to calculate the area of the sloping side. Then in the description, that's where we'll write the width exceeds 1.22 meters. It is assumed that if as long as it's beyond 1.22 meters, now the area will just take the total length times the vertical height. That one is the estimate that will give us the formwork in meters squared for the sloping side. The same area will be the same with that of the plain vertical. Plain vertical is this side behind the wall. So you'll take the total length 60 meters times the height of the retaining wall, which is 4.9. That's why we write here, add ditto but to plain vertical. But for the coding of the plain vertical, you will come to the system, then you will code class G fair finish 2. Okay, this is plain vertical 4, then exceeding 5 meters or exceeding 1.22 meters. So it shall be G2 4 5. Okay, then you shall remember that for this retaining wall, for the back side, there are areas where we have the piers, so you'll have to deduct that formwork, because if you look at the piers here, the piers have 900. So we were looking at this formwork for the whole vertical side, but there are where we have piers, and we have 16 piers. So we shall deduct these 16 piers whose length here is 900, then the height is 4.9. So there are 16 piers whose length is 0.90 and the height is 4.90. Now, this formwork we shall deduct from the plain vertical side. Why are we deducting? Because when we talk about the width of the piers does not exceed 1.22 meters, because you can see the width of the piers is 4.5. Okay, so we shall deduct it from the plain vertical, then we shall add it to where the width is for 450. 450 lies between 0.4 to 1.22. That's why we shall deduct it from plain vertical, then we add it to fair finish plain vertical with 0.4 to 1.22 meters. So the coding for this is class G, first division 2, 4 for plain vertical and 4 for the 0.4 to 1.22 meters. There are places where we have not calculated the formwork, including, if you look at the retaining wall, there is this side of the retaining wall, the sides. Okay, if we want to calculate the sides for the retaining wall and the sides for the piers, let's start with the side for the piers. Here we need the formwork. So we have two sides of the piers whose width is 450 and the height is 490. So there are 16 piers, two sides, each 450 by 490. Then for the retaining wall, we shall take the average width, because for the sides here it's narrow, it's wide. So 1500 plus 450 divided by 2, we shall get 0.98. Then the height 4.90, then we multiply by two sides. So this one will be the formwork for the sides of the wall. So you can see it's extreme sides of the retaining wall. Okay, so when we are quoting for the sides where we have the width, we shall just say ditto for the plain finish, plain vertical. But now it is the width. The width lies between 0.4 to 1.22 meters for the piers. You see, for the piers 0.45. But now yes, even for the sides of the retaining wall, it is between 0.4 to 1.22 meters, because 0.98 is still less than 1.22 meters. I hope that is clear. So we shall wrap up with the concrete accessories, the insert, which is the PV sides for the whip holes. So if you look at our drawing, the whip holes, we were not given a lot of details for them. First of all, we were just told for the whip holes, it's 150 millimeters whip holes at 22 meters centers. We were not told what type of pipe is used. So here we write a query sheet. We ask ourselves a question: is the insert made of PVC pipe 150, 1500 millimeters long? Then we say yes. All right, so we want to know how many inserts are there. So we shall take the total length 60 meters. They are placed at 2 meters center. So 60 divided by 2 meters. We shall get 30 inserts. So we shall say it's 30 number. Concrete accessories insert 100 millimeters diameter PVC pipe insert for whip holes 1.5 meters long. If you want to get the coding, we shall go to class G, then we'll go to where we have the accessories. Accessories, they are here in number 8. So first division is number 8. Then we'll go to inserts, number 3. Okay, then we'll go to, they are not linear inserts, they are other inserts. So they are calculated in terms of numbers. That's why we have just calculated the numbers. Everything we have to get from the CESMM4. So here we are told that we should calculate in terms of numbers. So they were 30 inserts, 30 number. So we just write concrete accessories first division. Second division, their inserts. Then we shall have to describe the other inserts, because now that it's not in the SMM, we are just told other inserts. So we shall just write the description that we have come up with in the question from the query sheet. All right, so it shall be like that. So we are now done with the taking off retaining wall using the CESMM4. In case you have any question, kindly write your question in the comment section and we are going to respond to it. In case you have any private tutorials that you would want to be done for you, you can contact us via email, which is still also in the description box. And also, in case you have any assignments that you would want help, you can also reach us via our email. So thanks a lot for watching, and in case you have any other topic that you would want us to cover in this channel, can write it in the comment section and we shall be able to look at it. So bye.